Welcome back. This is an Aleks training video on writing Lewis structures for diatomic molecules. Diatomic 2, so this is the easy one that you can get really complicated, but we're not going to do that right now. We're just going to stay nice in the baby into the pool, and then what you learn here can be taken somewhere else in the harder parts. So I've got two atoms in this ion. I've got nitrogen and oxygen. So I know that it's going to make at least one bond. We saw that there are sometimes double bonds where you're holding hands with more than one hand, two sets of hands, and then a triple bond where you would be holding three sets of hands, okay, or sharing 6 electrons. So in order to do a Lewis dot of this ion or any kind of a molecule, I need to know how many valence electrons should I have, okay, and then from there I can find out some other things, okay. So step one, I suppose, would be how are they put together? Well, this is easy because nitrogen and oxygen are touching each other. There's only two. If you're doing a more complicated one, you're like, which is the center atom? Is it all bounding to the carbon or is it doing something else? So in the case of this, it's nothing. You're just going to put a nitrogen and an oxygen next door to each other. Okay, so what next? How many valence electrons are in nitrogen? Okay, well, let me put a periodic table here so you can see. Nitrogen is in group 5, so there's 5. Carbon or oxygen, there's 6. All right, so you have 5 on nitrogen, 6. That's 11. So right now there's 11 valence electrons to play with, plus you've got another one because you've got the ion here, you've got an extra. So you have 12 electrons. Now it's easier to think in pairs because everything moves in twos. There's very few times that you're going to have one. So thinking, especially if you have an even number, think of if you have 5 and 6, that's 11 plus 1 is 12. Think of it as 6 pairs of electrons to play with. Okay. All right. So if you have 6, the first thing you do is try to give them a bond. Okay, so if that's 6, now I have 5 pairs to play with. Now you can start on either end. It really doesn't matter. If it works out, it'll work out perfectly. If it doesn't work out, it'll not work out either way you do it. So I don't care. You can start on the left. Remember that each one of these need an octet. All right, so I have 5 pairs to play with. So I'm going to make an octet around nitrogen. So there's 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs. And that's all the electrons I've got. So I can't play with any more. I can't add any because that's all that I've got to play with. Well, nitrogen obviously has an octet. I've got 2, 4, 6, 8 around nitrogen. Fine, works. Oxygen's a big problem. I need 8. I need an octet. I've got 2, 4, 6. So this doesn't work. This is not the Lewis dot structure of this. Okay, so what am I going to do? Okay, let's take some out. All right, so let's start over. My next guess is that if it doesn't work with one bonding pair, that you try a double bond. Okay, so we'll go back. I have 5 plus 6 is 11, plus 1 is 12. That's 6 bonding pairs. So I'm going to put one bonding pair here. I'm going to put another bonding pair here. Okay. All right, so now I have 4 left. I'll come over here and put 2, and come over here and put 2. Now, let's see if it works. Both of these double bonds are working for both sets. So this double bond is counting for nitrogen. This double bond is counting for nitrogen. So I've got for nitrogen 1, 2, 3, 4 doubles. That's 8. That's an octet. And then for oxygen, I have 1, 2, 3, 4 doubles. That's 8. That's an octet. So this one is the correct use. And remember, you could replace the double dot with a line, and you're going to need to also show that it's an ion. So I would do this. You're either going to, I'll give you the two possibilities. You're going to have nitrogen, okay, 1, 2, 3, 4, oxygen 1, 2, 3, 4, and then the whole thing is negative, okay, because this is negative. That's one possibility. Or you can do it with bars. So 1, 2, 3, 4, line, O, dot, 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 dot. This is still the same. So this would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then that has to show that it's an thing. So this would be or. And I think Alex would probably take either one of those. Okay, my guess. Okay, thank you.